All right, so we've already looked at multiplication algorithms when we're dealing with single-digit products with single-digit numbers. But what if our numbers start getting a little bigger? So here I want to multiply 13 times 3. Okay, so we're going to look at several algorithms for doing that. The first is just the concrete model where we model multiplication as repeated addition. So this is telling me to add 13 3 times. So here I've got 13 in my rows, 1 long and 3 ones. And I'm going to do that 3 times. And so if we add those up, we see that we get 39. Here you can see how this gets us to the standard algorithm. So this is the standard algorithm. So let's look at what's happening. The first thing we want is that our kids are going to think about numbers as tens and ones. 13 is 1 10 and 3 ones. So when we multiply 13 times 3, that's really multiplying 3 times 10 and 3 times 9. So that's what we're doing here. And then we can write that in a more expanded form in this middle equation. So here they've multiplied the ones, and then they multiplied 3 times 10 to get 30, and then we add those together to get 39. And then finally, once kids get a real good handle on what's happening, you can let them use the standard algorithm, which is what you're probably most familiar with. We're going to multiply the 3 times 3, and then we multiply the 3 times 1, and that 3 goes over here because really when we're multiplying that 1, we're saying 110. And so that 3 times 1 is 3 tens, and that goes in the tens place. Okay, so we've got the expanded algorithm and the standard algorithm here. All right, in general, when we multiply by a power of 10, if you think about the visual of the blocks, what we're doing is replacing each piece with the piece that represents the next higher power of 10. So we replace units with longs and longs with flats and flats with the blocks and so on. All right, so if I wanted to multiply 23 times 10, here I'm going to replace each of those pieces, and you can see that gives me 230. And so what students notice quickly is when you do that, really what you're doing is just tacking a 0 onto the end of that number. You're shifting each of those digits one place value to the left. We can use expanded addition, so we can use that property of what's happening when we multiply by powers of 10 to think about breaking our numbers down into their hundreds and tens and ones. So if I wanted to multiply 4 times 367, what I might do is break 367 down into 3 hundreds, 6 tens, and 7 ones. And so when I multiply now, I'm going to multiply in each of those place values. So I've got 4 times 3 hundreds, right? And then 4 times 6 tens, and then 4 times 7 ones. And then I can add those results together to get my final answer. So I get 1200 plus 240 plus 28, which is 1468. Okay, one of our goals is to help kids break problems down into smaller problems that are easier for them to handle, and this is one way for them to do that. All right, that's what you're doing here with the expanded algorithm as well. We're just not writing it out as much as we are on the left-hand side. So here we're multiplying 4 times 7 to get 28, and then to get the 240, I'm multiplying 4 times 60, right? Which is 4 times 6 tens, and so on. Okay, the partial products algorithm does this breaking down again. So we're going to break down our numbers into the tens and the ones to help us do our multiplication. Okay, so this one, it's nice to draw a rectangular array to help visualize what's happening. So I'm going to break 54 into 50 plus 4 And 23 I can think of as 20 plus 3. And so if I want to multiply 54 times 23, I just need to multiply in each of these little rectangles. So I'm going to multiply 50 times 20 to get 1,000. And then I want to multiply 4 times 20 to get 80. 3 times 50 is 150. And then 3 times 4 to get 12. And so my final answer is what I get when I add all of these up, which is 1,242. So this is called the partial products, right? Partial because I'm breaking these down into parts, and I'm taking each of the products of the parts. All right, this is preparing kids for algebraic multiplications. So, for example, think about when we multiplied 3 times 13, we were doing 3 times 10 plus 3. Well, just replace that 10 with an x, and now you're doing some algebra, right? 3 times the quantity x plus 3. I multiply the 3 times the x and the 3 times the 3. All right, so we're preparing kids. Even if you're not going to teach algebra, you're preparing their minds for algebraic thinking. Lattice multiplication. We call this the low stress method. So I want to multiply 23 times 14. So for the lattice multiplication, I'm going to sketch a lattice. I'm going to put 23 across the top, so 2, 3, and then 14 on the right. And I'm going to draw diagonals in each of the boxes from the upper right to the bottom left. And I'm going to switch colors here. And so now I'm just going to multiply within each box. So in this top right box, I've got 3 times 1. That's 3. I'm going to put the 10s on the top half and the 1s in the bottom half. 2 times 1 is 2, so I get 0, 2. And now below I've got 3 times 4 is 12, so 1, 2. And then 2 times 4 is 8, 0, 8. And now we're going to trace down the diagonals. Okay, a lot of times students like to get out their highlighter to remind themselves how we're going to go. We're going to add down these diagonals. So I get a 2. 8 plus 1 plus 3 is 12. I'm going to put the 2 here and carry the 1 into the next diagonal. So I get 3 and then 0 here. And then we're going to read our number this way. So this says that 23 times 14 equals 322. And you can check using either the standard algorithm or partial products or your calculator. Let's just do the standard algorithm quickly. So 4 times 3 is 12. I would put a 2 and carry my 1. 4 times 2 is 8, plus 1 is 9. And now this 1 is, think of as 10. So I have 10 times 3 is 30. We're doing a little expanded here. And 10 times 20 is 200. And we would add these together. I get 2, 12, carry your 1, 3. Okay. All right, so this is a low stress method. It takes care of the carrying for us a lot of times. Okay. Mental mathematics. So we want to get kids thinking in their heads about math, right? So how could they do these problems in their head? Well, they could front end multiply. So if I wanted to do 78 times 4, we break down those numbers. 78 is 70 plus 8, so I'm going to multiply each of those by 4 first. So 70 times 4 is 280, 8 times 4 is 32, and then add those together to get 78 times 4. We can use compatible numbers. So if you give a bunch of numbers to multiply, I've got 2 times 8 times 5 times 40 times 5. Let's use numbers that are compatible. 2 times 5 is compatible. It's a nice value of 10, right? 40 times 5 also, that gives us a nice value of 200. And so if I multiply those two together first and then multiply by 8, that's going to make the multiplication a little bit easier. Think money. Okay, a lot of times it helps to think money. So if I wanted to ask a kid what 84 times 25 is, well, if we think of 25 in terms of quarters, every time I get 4 quarters, I get $1, right? So 84 quarters, if I divide 84 by 4, that's $21. And then I need to convert back to cents because I'm thinking of this as 25 cents. So $21 is 2,100 cents or 2,100 cents. All right, we also want kids to get comfortable with estimating. So if I want to estimate, one thing I could do is front end estimate. So here I'm going to start by multiplying at the front. So 9 times 400 is 3,600. Then the next digit, 70 times 9 is 630. And then I'm going to add those two together. So it's about 4,230. I sort of ignored the ones here. All right.